Okay, welcome to another Orbiter 2010 video, and this video is going to be another installment in my Absolute Beginner Guide. Now, in the previous videos, we've taken a look at how to get into orbit, we've taken a look at how to launch from a launch site and plan to arrive in plane with a target object. We learned a little bit about raising and lowering the orbit, we learned how to align plane, and we learned how to rendezvous and dock. Now, something that's going to come up sooner rather than later for a lot of people is that they're going to want to take off from different bases. You know, they're not just going to want to take off from KSC all the time, and they're going to want to target other objects in space, like the Hubble telescope or Mir, or maybe some custom space station that you download and put into orbit around Earth. So we can't always rely on that 43-degree number that we came up with when we were learning how to take off and arrive in plane with the ISS. There are going to be times where that number is just totally inaccurate. You know, it's not going to be it's not going to be the launch azimuth that you need. So we need to learn how we can figure out what launch azimuth, which is just kind of a fancy way of saying heading, you know, what heading do we need when we take off. Now, since this is an absolute beginner guide, I'm not going to get into the equations. If you happen to be interested in the math, I'll put a link down in the description below where you can go to a website and you can read about all the equations, so you can sit down with pen and paper and you can actually calculate, you know, what heading you need to do, what heading you need in order to get to a target. And that is pretty interesting. I've gone through the equations myself, and I'm not a math guy at all, but I've gone through the equations and have figured it out, and it's pretty interesting to at least do that once if you happen to have an interest. But I'm assuming that absolute beginners have no interest in that, most likely. So what we really want to do, and there's a couple of things that we can do here, but I think the easiest thing is going to be to have beginners download an add-on. It's called Launch MFD. I was kind of avoiding this because I think that downloading and installing and that kind of thing can kind of somewhat get a little technical if you're not a computer person. But I really think this is the best way to suggest to the absolute beginner. I think this is the best thing to suggest, is to download this MFD. It's called Launch MFD, and I'll put a link to it in the description down below so that you can just click on that link. Now, I don't want to turn this series or this video into how to use your computer, so I'm not going to go to the website and download it and show you how to install it. I'm hoping that you can at least figure that part out on your own. So once you have Launch MFD downloaded and installed, and installing it's very simple, and you have to enable it in your Launchpad by going to the modules and enabling it. Then you would just bring up the MFD, just like you would bring up any other MFD. And once it's loaded, this may look very intimidating, but it's actually quite simple for our purpose here. All we have to do, no target over there so we're not confused what we're doing. All we have to do to find the launch heading is click target and then type in the object. You know, for example,
target selected,
the ISS. And now we can ignore almost everything that you see here. The only thing that we need to look at is the required heading, and that's going to be 42.88 degrees. Remember, I said it was almost 43 degrees, and that's where I get that number from. And that's if we are taking off and heading to the ISS when the ISS is coming up out of the south and going north. The other option is to catch it in the other direction, and if we're catching it in the other direction, then that heading that we're going to need is 137.12, or about 137. Believe it or not, that's all there is to it. So let's just take a look at a couple of different bases here just so we can see how this works. And then I'll show you another tool that you can use for getting launch heading. So let's press F3. Let's go to Wide Awake International. Actually, let's go to Coro instead, for at least first. So here we are at this base, and one of the interesting things about this base is that it's almost on the equator. You know, we're only 5 degrees north of the equator. So let's put in the ISS from here and see what happens.
Target selected.
You can see now we have, again, ignoring all this other information, we don't even need to look at any of that because it's just too confusing. Now we know what our heading needs to be. It's not 43 degrees. This time it's 35.89. So you can see the point here is that the launch heading, it depends on your launch site. It's going to be different for every single launch site that you're at. In fact, at a launch site, the heading can vary slightly depending on where you are at on that launch site. It wouldn't vary by much at all, but if you were at one runway up at the northern end of the base versus the runway at the southern end of the base, it could vary just a very small amount. And then the other thing that dictates what our launch azimuth is going to be is the object that we're targeting. Again, in here, this is the ISS, and we can see the headings here, but if we target Mir,
target selected.
Now we have a new set of headings that we would have to follow, and that's all there is to it for the launch heading. Now, if you don't want to install an MFD because maybe you don't want to pollute your orbiter installation or something like that, or maybe you just don't like the way this looks, or who knows why. Different people have different reasons. When I was brand new to Orbiter, I was very, very picky, very finicky about what I would actually add on to my installation because I wanted to be as close to vanilla as possible. So maybe you don't want to add this MFD. That's okay. We have other options. There are a couple of tools that you can download that would exist outside of your Orbiter installation, so you wouldn't have to add them to Orbiter. They would just be programs that would run separately. One of them is called Space Calculators version 2, and make sure, and again I'll put a link to this in the description as well, but you make sure you get the V2 and not the older version. And you'll notice when you bring it up, it's just a very simple Windows program, and it has these 4 options. The only one we care about here is the launch azimuth. So I'm going to go ahead and click that, and let's go back to KSC here for a moment. So we click the launch azimuth, and it's asking us some questions. It's asking us target's inclination, it's asking us launch latitude, and you're thinking, I don't know any of this stuff. How do I even figure that out? Well, I'll show you. It's pretty straightforward. So let's come over here and let's bring up Orbit MFD, and we're going to target the ISS. And you'll notice over here it has all this the orbital element information. And if you go down this list, you'll see here, inclination. And you might be thinking, aha, that's what we need. And you're right halfway, maybe even 90% correct. There is one catch, and it's very, very important that you understand this. The Orbit MFD has 2 frames of reference. One of them is the ecliptic, the other one is the equatorial frame. And I'm not actually going to explain the difference there. If you're interested, you can look it up in the orbiter.pdf in your doc file, maybe read a little bit about it. The only thing that we need to care about for the sake of finding the correct launch azimuth is that we need the frame of reference to be equatorial. So it defaults to ECL. That means we have to press this button, and when we do that, you'll notice this will change. It'll change significantly. It's no longer 74.51, it's now 51.59. And you can well imagine that many degrees of difference could make for quite a different outcome. So this is the inclination that we need. We have the frame of reference set to equatorial, and we need to know this inclination. It's 51.59. So that's the number we're going to put in here that's the first number we're going to put in, 51.59. The next thing it's asking us for is our launch latitude. And again, you might be wondering, I don't know what the launch latitude is, but fortunately it's very easy to find in Orbiter. In fact, it's right here on MapMFD. Wherever you are at, MapMFD is telling you what your latitude and longitude are. And we only need to know our latitude. It's given to us right here, 28.60. So we're just going to go ahead and put that number in, 28.60. Now we have 2 more questions. What is the velocity? And it might be a little bit better if it said hour velocity or something, but the first velocity it's asking for is what is our velocity. And you're probably thinking it's 0 because we're sitting here, we're not moving. Well, that's true, but that would be our relative velocity. Our relative velocity to the ground is 0. But we are actually moving because we are on the Earth and the Earth is spinning. And the orbit, the velocity that it's asking for is given to us here, and it gives you a good indicator, orbit MFD. So if you come down here, you can see that our velocity at this latitude is 407.9. So we're going to put that number in. And the last bit of information that it needs to know is the velocity of the target. And that's over here, 7.691 K. And it's important that you put that number in as 7,691 and you don't try to type it as 7.9 because that would be a very different number. So it's 7,691, I believe it was. Yeah. So you put those 4 pieces of data in, and they're all right here, just map MFD and orbit MFD, and then you hit calculate, and it gives you, voila, the same information that we got from launch MFD. We get here 42.8 and 137.2, so there's a slight difference in the way they round their numbers, but basically it's the exact same number. So again, this is just another tool that you can use if you don't want to install something into Orbiter itself. Let me close that out, and let me go ahead and exit out of Space Calculators. And let's go to one more launch site. Let's go to Wide Awake International, because this gives us a different latitude. And I'm going to show one last calculator. And I chose the worst base possible because this one's not here, so let me pick a different base. That one's not entered into that database, I forgot about that. Let's go to this one. This is actually a good choice too. So here we are, we're at, I'm terrible with pronunciations, Baikonur, it's whatever the pronunciation is. And we're going to put in the ISS, so that's going to be our target body, and we don't actually have to provide the inclination because this particular launch calculator has sort of a built-in database, probably just a text file with all this stuff, but it has the correct inclination already here. So when you click this object, the ISS, it fills in for you the 51.57. That's slightly different than what Orbiter is showing. It's only a different of 0.02. Orbiter is showing 51.59, so I'm not quite sure. We could always, I suppose, override that. But the idea is just that this information, when you click it, it fills in these fields for you. And then again, our latitude, when we click on here, it tells us that our latitude's 45.92. We can double check that in MapMFD, and MapMFD agrees it's 45.92. And then this one does the calculation a little bit different. Instead of asking for velocities from OrbitMFD, it asks for the altitude, basically our target altitude, and from the target altitude, it can correctly derive the velocity. So this calculator gets to the same result, just doing the equations in a slightly different fashion. Anyway, once you have your 3 pieces of data selected, you just hit calculate, and here it gives you the launch azimuth. Again, if the ISS is coming out of the south and heading north, this is the heading that we need, and if we're going the other way, this is the heading we need if we're going to be heading south. Let me go ahead and quit out of that calculator. As you can see, the launch MFD is probably by far the easiest for everybody, because all you have to do is just target the object, ISS for example,
selected. And
you've got these numbers right here. You don't have to provide your launch latitude, you don't have to provide the inclination of the object. This MFD can basically do all of that for you. This MFD is capable of quite a bit more. I'm not going to get into that. That's a whole set of videos unto itself. I think that's basically everything I could think of that I wanted to cover. This is actually the second time I recorded this video because the first time I just wasn't happy with what I went over, but I think I got it all this time. If there's any questions at all about this launch heading stuff, how to calculate it or anything like that, go ahead and leave your comments and questions down below. If you like the video, leave me a comment, hit the like button, subscribe to the channel, and I will see you in the next video. It's not going to be it's not going to be the launch azimuth that you need. So we need to learn how we can figure out what launch azimuth, which is just kind of a fancy way of saying heading, what heading do we need when we take off. Now, since this is an absolute beginner guide, I'm not going to get into the equations. If you happen to be interested in the math, I'll put a link down in the description below where you can go to a website and you can read about all the equations. So you can sit down with pen and paper and you can actually calculate, what heading you need to do, what heading you need in order to get to a target. And that is pretty interesting. I've gone through the equations myself, and I'm not a math guy at all, but I've gone through the equations and have figured it out, and it's pretty interesting to at least do that once if you happen to have an interest. Okay, welcome to another Orbiter 2010 video, and this video is going to be another installment in my absolute beginner guide. Now, in the previous videos, we've taken a look at how to get into orbit. We've taken a look at how to launch from a launch site and plan to arrive in plane with a target object. We learned a little bit about raising and lowering the orbit. We learned how to align plane, and we learned how to rendezvous and dock. Now, something that's going to come up sooner rather than later for a lot of people is that they're going to want to take off from different bases. They're not just going to want to take off from KSC all the time, and they're going to want to target other objects in space like the Hubble telescope or Mir, or maybe some custom space station that you download and put into orbit around Earth. So we can't always rely on that 43-degree number that we came up with when we were learning how to take off and arrive in plane with the ISS. There are going to be times where that number is just totally inaccurate.